Professor Doug, I want to know more about logic as a tool for making an effective case for something.
Then you need to understand the difference between formal or deductive reasoning and informal or inductive reasoning. I think of this as the difference between wearing a tuxedo and just going about in shirt sleeves. Formal reasoning is very limited in its applications, although it is the standard for what we do with mathematics.
I never thought of a math problem like wearing a tuxedo. Why do you say that?
When you want to think in a very formal manner, you present statements that allow no exceptions, and then you have another statement that recombines the information. In your high school geometry, for instance, you always started with statements that were either true because of initial definitions or assumptions, or true because they had already been proven. You reasoned step by step from what was given as true. We call these your premises, and arrived at what now had to follow. We call this your conclusion.
Do you mean I cannot use formal reasoning in real life?
No, you most certainly can, as when you cite rules or principles as your premises. For example, let's start with the idea that only students properly enrolled in a course may receive a passing grade, and then add the fact that your friend Joe has officially dropped the course and so is no longer enrolled. What more can you now be sure of?
I would have to say that Joe will not get a passing grade.
Exactly. Now in real life it is difficult to make statements that do not allow for exceptions. Most of the time we reason on the basis of similarities of one kind or another. We may know a lot about past situations, for instance, so we predict the future based on these similarities. This is where statistics comes into play. We call this inductive rather than deductive reasoning.
Wait a minute. Statistics is a branch of math, and you just said that math had us use formal or deductive reasoning.
Yes, indeed. Statistics is a definite exception, however. Here we talk about probabilities rather than absolute certainty. Now for practical purposes that is often the best we can do. I can calculate the odds for or against something taking place. That part itself is deductive, of course, but I must always allow for the possibility, no matter how slight, that any actual event beats the odds.
I understand. But outside of statistics, when do I use inductive reasoning?
Almost all the time when you need to show someone that you have a good case. Remember, we are not talking about how our minds actually work, but about how we attempt to present an informed judgment. We can be making a prediction about the future, or we can be trying to explain something that has happened in the past. It is what a lawyer does in front of a jury. A judge must use deductive reasoning in applying legal principles at a trial, but lawyers and juries have to reason inductively. In a criminal case, the evidence should support the verdict beyond a reasonable doubt, and in a civil suit we expect a verdict to be based on which side appears to have a stronger case.
In my other classes I learn about scientific reasoning. Is that deductive or inductive?
Actually, it is a bit of both. We imagine how we might explain something, usually on the basis of similarities or analogies, and then we systematically try to prove ourselves wrong through our experiments. Technically, we begin with a hypothesis that there might not be a difference when we insert or remove a variable and then see what happens. If there is a difference, then we have disproved that original hypothesis, and if we can keep doing this we feel we may be getting closer to the right explanation.
So the original hypothesis involves inductive reasoning, and the way I attempt to prove it wrong is deductive?
Correct. Now for either deductive or inductive reasoning, the real trick is watch out for mistakes in how we apply these ideas. But that is something for another conversation when we can talk about both formal and informal fallacies.